Um, so yeah, in this chapter, we are talking about spherical coordinates. And so what I've got here is just a simple equation, rho equals 5. And they're going to want you to describe these surfaces, so you just have to kind of get used to them, I guess. One reason for that. Well, we know some of the conversions, like, for example, we know that rho squared equals, well, it's the kind of the equivalent, x squared plus y squared equals r squared. Rho squared is the 3D equivalent of that. X squared plus y squared plus z squared is what rho squared equals. And the one way that possibly we could figure out what this is if we had rho squared here, which we can do that very easily by just squaring both sides. Rho squared equals 25, and then rho squared is x squared plus y squared plus z squared, which that equals 25. Hopefully that's familiar. That's one of the very first three-dimensional graphs we talked about. That's the sphere, right? This is a sphere, radius 5, and the center's at 0, 0, 0. And so rho equals 5 is a much simpler way of writing that now. And yeah, that makes sense, because remember what rho is. Rho is it's the distance from the origin to the surface. And so if rho equals 5, that's meaning the distance from the center out to the surface is 5 all the way around. And so yeah, you've got a three-dimensional circle in essence. But anyway, rho equals 5. It's a sphere, radius 5, center 0, 0, 0. Which that also, before I do the next one, that's why one reason these are called spherical coordinates, because yeah, the spheres are just so nice in these coordinates. Anyway, what about phi equals pi over 3? Remember what phi is? Phi is the angle, like if here, three-dimensional, whatever. If that's from the origin out to the surface is there, then phi is that angle you make with that line to the surface from the origin. So this is saying phi is locked in to be pi over 3, and so that means no matter what how far you're out from the to the surface, no matter how far you're out there, no matter where you are as far as the XY plane is concerned, the phi is always pi over 3. So let's kind of think about that. So if we're just in the XY plane, then we're talking about pi over 3, that's 60, so it would be more laid out there. So on the XY plane, we're there, and then all the other, if you go 360 degrees around that, 2 pi, I guess would be a better way to phrase it. What you wind up with, is, so if I go back into the board at pi over 3, if I'm this side, I'm at pi over 3, if I'm Out here, I'm at pi over 3, and so, yeah, what you wind up with is a cone. So cones are really nice in spherical coordinates because you can get a cone by just simply labeling your phi there. Now, question for you, all right, so that's kind of the cone that's above the xy plane. How would I get one that's below the xy plane? Well, it's going to be above the xy plane if phi is between 0 and pi over 2. Let's say, all right, so let's say I've got, call it angle alpha. And phi equals alpha. That's going to be something like that, right? So to get it below the xy plane, I would just make my phi somewhere between pi over 2 and pi, right? Call it beta. Oops. Then when I go phi equals beta, since I'm more than pi over 2 and I'm less than pi, yeah, that's going to be down below the xy plane. Something like hard to draw since anyway, because yeah, your beta angle is more than 90 and less than 180, so. All right, enough of that. Okay. All right, now, some equations going from Cartesian equation to spherical equation. That's what I'm going to do here next. So number one, x squared plus y squared equals 4. So it's a simple little equation there. So there's different ways. If we recall here, remember in spherical coordinates, x is rho sine phi cosine theta, and y is rho sine phi sine theta, right? That's our direct conversion from spherical to Cartesian. And z, just for that matter, z is rho cosine phi. If we just use that, then these two, we can directly substitute those in. So we're squaring this, so it'll be rho squared sine phi squared phi cosine squared theta. And then the y squared would be that squared, so it'll be rho squared sine squared phi sine squared theta equals 4. Which is, I guess, does the trick, but if you simplify it, make it even nicer here, it turns out it's not too bad. And the way you simplify it is, notice we can factor out the rho squared there and the sine squared phi, but that'll leave us cosine squared theta plus sine squared theta. But what do we know about cosine squared plus sine squared? That equals 1, right? So this simplifies to just be rho squared sine squared phi equals 4, which both of those, rho and sine of phi, remember phi ranges from 0 to pi, so it's always, sine of that is always positive. So anyway, if you square root both sides, you would get a simpler conversion there. Is that okay? Question or concern? Too bad. So yeah, we can, and we'll do some of that, some other stuff here in a second, but so convert this one to spherical, x squared plus y squared plus z squared plus 2z equals 0. Which on that one, we don't want to use the, well, we'll use one of those, but for x squared and y squared, we don't want to do that because what does this right here equal in spherical? What does x squared plus y squared plus z squared equal? Got it right there, don't I? So if I have x squared plus y squared plus z squared, that can just be turned over to rho squared. Now, I still have z, so I need it in spherical. Well, that's where we would use the rho cosine phi. That would be good enough conversion there. No simplifying, I don't think of that. Is that right? Okay, now.